In this video, I'll be going over 5 absolutely amazing Scratch hacks. These tips and tricks will help you considerably enhance your games and take them to a whole other level. In case you didn't know, this is episode 2 in my tips and tricks series, and without further ado, let's jump right into it. At number 5, we have endless scrolling backgrounds. These have insanely wide applications in pretty much every single game. The purpose of this is to just give an illusion that the player is moving forward. For this effect, you will need a background that encompasses and covers the entire costume editor. I'll use this geometry dash background. Just note that this background needs to look good next to itself, otherwise the result of this is not going to be too pretty. Anyway, here's how you can code this into existence. We will use 2 variables. The first is called background X. The second variable is called clone ID, and we will make sure to set it for this sprite only. Let me quickly explain what we will do. We will have 2 different clones while the sprite itself will be invisible. One of the clones will be positioned at the center. The second clone, on the other hand, will be positioned extremely to the right. As the game goes on, we will move both the clones in unison leftwards until the first clone is completely off the screen. After this, before a single frame, we will move both the clones to their right by the stage width. This can just go on again and again and again, giving us a seamless animation. Back to the code. Set both background X and clone ID to be 0. Then create a clone. After this, change clone ID by 1 and then create another clone. This way, the first clone will have a clone ID of 0 while the second clone has a clone ID of 1. Hide, and within a forever loop, check if background X is -480. If yes, then set it to 0. Outside the condition, increment background X by -1. In essence, this will create 2 distinguishable clones and have a background X variable that will loop repeatedly from 0 to -480. Now we just have to move the clones in accordance with the variables. So when a clone is created, within a forever loop, set the size to 400, then go to X, background X plus 480 times clone ID, Y0, and finally set the size back to 100. The changes in size that we're doing back and forth is to fix a common Scratch bug that relates to stage fencing. Anyway, with this, you should have an endless scrolling background. This is quite nice, but in some cases, we might want the background to move a little bit faster. Not a problem, because this can be added with just a small modification. In the main forever loop, instead of changing background X by -1, change it by something like -2 or -3. And that's it. This should increase the speed of the animation. Like I said before, this has countless applications, so feel free to customize the same. At number 4, we have Scratch to .exe. This is how you can convert your online Scratch project into a .exe file. This is extremely useful when you'd like to share the output of your project in a professional format, or if you just don't want someone who is viewing your project to be able to see your code. Here's my Geometry Dash project completely ready for conversion. First, download your project as a .sp3 and save it in a convenient location. I'll keep it in this particular folder. Next, visit the URL packager.turbowarp.org on your browser. After the page loads, select the option File and choose the one that you just created. A new list of options should drop down below this, and I'd recommend keeping pretty much all of these options as they are. For the environment, choose Electron Windows if you have Windows, and if you have a Mac, then click on Other Environments and choose Electron Mac OS. Within the application settings, change the package name to your project. This is what your .exe file will eventually be called. After this, click Package and download as a zip file. Once this has been downloaded, navigate your files and extract it to whichever folder you please. Now go into the same folder and select the .exe file. This should give you the .exe output, and you should be able to run your project the same way you're used to. Super useful, especially when you just want to show the project output to someone like a friend. At number 3, we have FPS Counters. These are super useful to detect instances where your project lags, and also just as a nice thing to have for each one of your games. Here's how you can create a tracker in Scratch. FPS stands for frames per second, and it's used to detect the frequency of screen refreshes. Let's say that I have a small oscillation script such as this for my project. To get the FPS counter, first you need to create a variable to store the same. Then perform the following operations. When the green flag is clicked, enter into a forever loop. Each time, set the FPS variable to be the rounded value of 1 divided by the timer. Finally, reset the timer. If you test the program, you should get the FPS counter running at around the 30 mark. So, how does this work? Remember that the variable should measure the number of frames per second. In this loop though, we will pass by only a single frame as there's just one block. Also, since we're resetting the timer before each iteration, the number of seconds for that frame will just be the value of the timer. So just plugging these two values into that formula that we have, we get FPS is equal to 1 divided by the timer. This method is simple and it's pretty easy to include in your projects. But sometimes we cannot use this method because we are already using the timer somewhere else. For example, if you watched my first tips and tricks video, then you will know that the timer block can be used to create a stop sign detector. So this second method involves making an FPS counter without using the timer. Let's go over this from the start. It's easier if we create a block and you can call this FPS tracker. Add an input for the initial day and make sure you do not run without screen refresh. For the block definition, add a very strange looking wait 0 seconds. After this, like before, set the FPS variable to be the rounded value of 1 divided by 86,400 multiplied by days since 2000 minus the initial day. And that's really it. When the green flag is clicked, add a forever loop, and each time within this loop, just use this block with an input of days since 2000. And well, if you test the program, the FPS counter should work almost identically as before. So how really does this work? I'll go over the logic step by step. The days since 2000 block doesn't just store the integer value of the days that have passed, it also stores the exact decimal value. For example, if the time is 12 noon in the afternoon of 1st January 2000, this block will return a value of 0.5, not 0. In fact, this is accurate down to the milliseconds. You can see this block update itself constantly if you show it from the sensing category. You can think of this block as being a measurement of time with its unit being days. When we use this block and give the days since 2000 as an input, it stores the time before a frame is run in the initial day parameter. The wait 0 seconds block just forces Scratch to run a single frame. It's actually a super important part of this. After this wait, the subtraction of these two blocks will give the time that it took to run that single frame, but the unit of this is in days. Since we want the frames per second and not frames per day, we convert this unit to seconds. Basically, multiply by 86,400, which is the number of seconds in a day. This uses the exact same logic as before, and while it's slightly longer to code, it's actually even more accurate. At number 2, we have custom fonts. This is how you can import custom fonts inside Scratch itself. The default Scratch costume editor has options for just 9 fonts, and to be honest, most of these kind of suck. I'll share 2 different ways for getting your custom fonts inside Scratch. For method number 1, you can visit the website in my description. This is a tool created by Haven that gives you access to a much larger variety of fonts. You can really just enter the text that you want and choose the font as well. In my case, I'll go ahead with Comic Sans. Next, download the SVG file and then import that into the Scratch costume editor. And that's it. You should have customizable text as well that you can edit to your satisfaction. The only real drawback to this method is that you can't get your own specific font inside Scratch and are kind of bounded by the ones that are available. So for that, here's method number 2. First, type out your text in the editor itself and then export it as a .svg file. Next, go to its location and open with Notepad. After this, change the bottom font family attribute to refer to the font that you'd like. This time, I'll choose Garamond. Save, and if you import this costume back into Scratch, then you will have an editable custom font. While you can always export the text locally as an image, the advantage to these two methods is that you can change the text within the Scratch editor itself. If your font happens to be cut out like this, then add a few spaces to the end and a couple of empty lines at the beginning. Center this and your font should now be working the way you expect. This isn't perfect, but it's the best workaround to Scratch's limitations. It is important to note, however, that the user would be able to see this custom font only if they also have the font downloaded on their computer, so use this trick keeping that in mind. Finally, at number 1, we have invisible Scratch code. Just like the previous hacks, there are multiple ways to do this. I'll share with you my recommended way, which is both the easiest and safest. First, open your browser and go to the official Scratch website. Then, search %15. The results of this are not important. What matters is the tiny square on the search bar. Copy this and then get onto one of your Scratch projects. I'm back here on my Geometry Dash project, and as you can see, this has quite a bit of code within it. Now, choose any sprite that you want and then create a new variable. Paste the same square for its name and everything should be good, right? Well, maybe not. Try switching the sprite and well, all the code should literally be invisible. What? Now, this is reversible by deleting the empty variable and going back, but this is still a very cool way to prank your friends. Just avoid sharing these projects on the Scratch website, as this is against terms of service. There are actually quite a few ways to achieve the same effect, such as modifying the JSON or even coming up with some very clever unremixable code, but these could end up damaging your projects, and so I don't really recommend them. With that said, thanks for watching. Make sure you leave a like if this helped you out, and until next time, peace out.